All right, guys, so we're off and running here with sections 1.1 and 1.2. Okay, this is kind of a two-section day. I'm hoping this is going to be a review for you guys, some definitions, some examples, some rules, all stuff that I'm assuming you have done before. But obviously, if you have any questions on anything, okay, make sure that you let me know, whether that be through email, in class, okay, through Google Classroom. All right. So we're going to start off here with 1.1. The title of this section is evaluating expressions. All right. So just to go over a couple definitions to start, you see a couple highlighted words over here. A variable. A variable is a letter that is used to represent one or more numbers. Okay. Talking a little more about variables, guys. You'll see X and Y used a lot. All right. You will see A and B used a lot. But as you guys know, I'm sure by now, it can be any letter. You can use any letter to represent a variable. Okay, so more things in this little section here. Okay, we got expressions consisting of numbers, variables, and operations. An algebraic expression or variable expression is an expression that includes at least one variable. Okay, so if you take a look at this chart here below, you got some algebraic expressions in there. You got some meanings and you got some operations. One thing a couple things actually I want to highlight here, guys. Okay, 5 times n, okay, you will see most written like that. We're going to get away from the dot and we're going to get away from the parentheses. Multiplication is actually the only operation that does not require the use of a symbol. Okay, so 5n means 5 times n. All right, with division, you're going to see the fraction bar used more frequently now. You're not going to see the division symbol there. You're going to see a fraction bar. Okay, and then obviously you got your addition, you got your subtraction there. Okay, again, this should be nothing that's crazy new. Just a quick little refresher there. Now, when we talk about evaluating an algebraic expression written down here, okay, it asks us to substitute a number for each variable, perform the operation, and simplify the result. I'm going to simplify that definition, guys. Anytime you're asked to evaluate, you are finding a number. Okay, so anytime you're asked to evaluate, that means you're expected to find a number answer. Okay, so let's get a couple examples out of the way here, guys. I'm just going to change the color of my pen here so we got example problems. Okay, so we are going to be evaluating here. So if I asked you to evaluate, I'll start real simple here, guys. If I asked you to evaluate y plus 6, and I wanted you to do that when y is equal to, say, 9, okay, you would replace the variable with the value for that variable. So we're going to replace this y with that 9, okay? That's called substituting, something you guys have also probably seen before. So we're going to substitute. So that 9 is going to replace that y. So instead of y plus 6, it would be 9 plus 6, which would be equal to 15. So our answer to that problem would be 15. Okay, we found a number as an answer. So let's say I asked you to evaluate 6n, okay, when n is equal to, say, 7. Okay, same thing. You're going to substitute. That 7 is going to replace that n. Now remember, when you see 6n, that's the same thing that's saying 6 times n. So we are doing 6 times 7, which would be equal to 42. Okay, there's your evaluated version of that expression. Now, in order to evaluate, just keep in mind, they have to give you a value for the variable. You would not be able to evaluate if you didn't have a value for the variable. Okay, hopefully this is pretty basic so far. Okay, moving right along here. Okay, exponents. Okay, some exponent work here. Expressions using exponents. We got 3 main definitions here, guys. You got a power, you got a base, and you got an exponent. It's all explained right here. Okay, the base is the big number. Okay, so in this expression that we're working with here, the base is this 3 right here. That's your base. The exponent is the little number, which is a 4. Okay, the power is actually the whole thing. So this right here would actually be a power of 3. Okay, because 3 is the number that you're raising, all right, to the exponent, right? Now, when you have an exponent, that's telling you how many factors of that number there are, how many factors of the base. Okay, so with this numerical expression we got right here, we got 3 to the 4th power. That means you have 1, 2, 3, 4 factors of 3. The common error, okay, and I'm sure you've seen this before, the common error is that 3 to the 4th power is equal to 3 times 4, which is 12. That's no good. Okay, this is no good. So I'm going to circle that and put a slash through it. Okay, that's no good. Okay, 3 to the 4th power is not 3 times 4. So we got a couple examples over here. Ask us to write the power in words and as a product. Okay, so 7 with a little 1, that would be 7, okay, to the 1st power. Okay, and that's just going to be 1 factor of 7. So that's just 7. Okay, that's pretty straightforward there. Down here, 5 with a little 2, that is 5 to the 2nd power. Okay, you could also write that 5 squared. You can use squared when the exponent is 2. And that means we got 2 factors of 5, which would be 5 times 5, which you should know is 25. So the common error is to say that 5 to the 2nd power is 10. It's not 10. Okay, down here, this is 1/2 to the 3rd power. And 1/2 to the 3rd power, right? That could also be written 1/2 cubed. Okay. Now that's going to equal, all right, 1/2 to the 3rd power. Now with fractions, you're actually going to take that exponent and give it to the numerator, which is the top, and the denominator, which is the bottom. We're going to do way more with rules of exponents later. This is still pretty basic. So 1 to the 3rd power is 1 times 1 times 1, which is 1. Doesn't matter how many times you multiply 1 by itself, it's always going to be 1. On the bottom, you got 2 times 2 times 2. 2 times the first 2 is 4. 4 times that last 2 is 8. So the answer there is 1/8. Okay, and then that last example down there, z with a little 5, that is z to the 5th power. Which would be 5 factors of z. 3, 4, and 5. I can't go any further with that, obviously, because that is a variable, so I can't multiply them because I don't know what z represents. So those are just some basics there with exponents, okay? Moving on to the next page here, okay? All right, we're back to evaluating. Now we're going to evaluate the expression when we have some exponents. So for part A here, we got x to the 4th power when x is equal to 2. So again, you're going to substitute that 2. It's going to go in here for x. So you'd have 2 to the 4th power, which is going to be 2 times 2 times 2 times 2, right? 4 factors of 2. All right, let's break this down. So the first 2's multiply to make a 4 times 2 times 2. This 4 times 2 makes an 8. Times that last 2 would make a 16. So when I evaluate there, I got 16 as my answer, right? So I got a number as an answer. Letter B, okay? N to the 3rd power when n is 1.5. So this would be 1.5 to the 3rd power, which would be 1.5 times 1.5 times 1.5. Now, you're going to need a calculator here, so I'm going to get my calculator out. Obviously, you can't see my calculator, but 1.5 times the first 1.5. Okay, so I'm doing this 1.5 times this 1.5. That's 2.25 times the remaining 1.5 gives me a final answer of 3.375. Okay, 3.375. That's my final answer there. Down on the bottom, some more evaluating there, guys. I'm not going to do numbers 9 and 10. Okay, you can do these on your own if you want. 9 and 10 are very similar to the 2 problems that we just did. If you want to try those on your own and check with a calculator, that's fine. Number 11 is a fraction one, so I'll kind of do that one for you, just to give you another example. D to the fourth when D is equal to 1/3. So you're going to have 1 over 3 raised to the fourth power, which is 1 to the fourth power on top of 3 to the fourth power. So you got 4 factors of 1 on the top, which is going to be 1. We said that earlier. It doesn't matter how many times you multiply 1 by itself, you're always going to get 1. On the bottom, you got 4 factors of 3. Okay, so we'll break that one down a little bit. So the first two 3's make a 9. Then you got 9 times 3 times 3. 9 times 3 gives us 27. Use a calculator if you're unsure. And 27 times 3, you might need a calculator for that, is 81. Okay, so the bottom of my fraction, okay, otherwise known as the denominator, is 81. Okay, so my final answer for example number 11 there is 1 over 81. Okay, again, hopefully this is all a review for you guys. Okay, section 1.2, like I said, this is a 2-section day. We talked about evaluating, we talked about some exponents, some basic math operations. Now we're going to tie that into order of operations. Okay, all right, PEMDAS. You guys are all familiar with PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply and divide. Guys, I'm going to highlight M and D, multiplying and dividing. Okay, we are going to tackle those. Erase that. I made a little mistake there. Okay, we are going to tackle multiplying and dividing. Okay, left to right. And I like to say that because they are in the same family. I'm going to do the exact same thing with addition and subtraction. Because addition and subtraction are in the same family, we are also going to tackle them from left to right. So anything in parentheses or any sort of grouping symbol, you could also see brackets. You could also see braces. They are going to get tackled first, inside to out. You'll see when we get into some of the examples. Then you're going to tackle your exponents, if there are any multiplication and division, left to right, and then any addition, subtraction, left to right. Okay, so let's take a look at some examples here. All right, the first one, we got 27 divided by 3 to the second power times 2 minus 3. Okay, if we were operating with PEMDAS, and I'll write it up here so you can follow along with me, we would start with the parentheses, which in this problem there are none, so I can skip that step. Then I would go to the exponent. There is an exponent, 3 to the second power. That's 3 times 3, right? 2 factors of 3, which is 9. Everything else comes down. 27 now divided by 9 times 2 minus 3. Okay, so I did the parentheses, I did the exponents. Now, here's where you might make a mistake. You got to be careful. It says multiplication next, but remember, when you have multiplication and division, you go left to right. So multiplication and division are going to be tackled left to right. They're in the same family. So I'm actually going to do the division first. 27 divided by 9 is 3 times 2 minus 3. Now I have multiplication and subtraction. Multiplication comes before subtraction. 3 times 2 is 6. 6 minus 3 gives me a 3. Again, getting back up here, evaluate means to find a number. I found a number. Okay? Some examples down at the bottom there that are very similar to the example we just did. Okay? Try those on your own if you want. Okay, make sure you're following PEMDAS. Check your answers on a calculator. Be careful when you type them in on a calculator, guys. Okay, make sure you're typing them in, exactly the way you see it on the in the problem. Okay, so there's some examples down here if you want to kind of try some of these on your own. Got some exponents in there, some addition, subtraction, multiplication. All right, if you want to work through some of those on your own. Okay, moving right along. Now we're going to do some problems that have some grouping symbols in it. So now we're going to incorporate parentheses. Okay, this right here is just a reminder that all grouping symbols indicate that operations inside the grouping symbol should be performed first. So in example number 1, division comes before addition. But because the addition is in the parentheses, that's what I'm going to do first. 8 plus 4 is 12. 12 divided by 2 would give me a 6. So that's pretty straightforward there. So the answer number 1 is 6. Okay. Number 2, okay, we got 2 sets of parentheses. So you're going to handle them separately. Okay. So 2 minus 1 over here would give me a 1. 6 minus 1 over here would give me a 5. Now, this would still be wrapped in parentheses. This would still be wrapped in parentheses. Okay. If you guys were in class with me right now, I would ask you what that means. Hopefully you know by now that when 2 numbers are next to each other in parentheses, that means multiplication. So this means 1 times 5. So my final answer is 5. Now, it can get confusing when you have 2 sets of parentheses like you have in number 3. Okay, when you have 2 sets of parentheses like you have in number 3, you start on the inside and you work your way out. So in number 3, we're going to start with that set of parentheses and work out. So 6 parentheses 5 minus 9 divided by 4 minus 1 gives me a 3. Now I can tackle this expression right here. I got subtraction and division. Division comes first. 6 parentheses 5 minus 9 divided by 3 is 3. I stay inside the parentheses. I got to get them done first. 5 minus 3 gives me a 2. So I have 6 parentheses 2, which is another way of saying 6 times 2, which finishes me off with a 12. So my answer there is 12. Okay. So when you have 2 sets of parentheses, you start inside and you work your way out. Okay, I think this is the last thing here. Oh, we got a couple more down there. Okay. The last thing here, as far as order of operations is concerned, when you have a fraction bar, okay, we're talking about a fraction bar now. A fraction bar can act as a grouping symbol. Evaluate the numerator and denominator before you divide. So you see kind of how they did this example here. I'll show it a little more off to the side. You got 8 plus 4 on top of 5 minus 2. This fraction bar right here is division, right? We talked about earlier a fraction bar meaning division, okay? You can't divide until the top, the numerator, is simplified, and the bottom, the denominator, is simplified. So 8 plus 4 is going to give me a 12. On top of 5 minus 2 is going to give me a 3. Now I got a nice, easy division problem to take care of. 12 divided by 3, that's going to give me a 4. So when you have a fraction bar, make sure you simplify the numerator, the top, first, simplify the denominator, the bottom, second, and then divide. Obviously, all while using your order of operations. Okay. All right, this last example here, example number 3, evaluate the expression when x is equal to 4. All right, so I'm going to have to substitute this 4 for x. So this expression on top I have 9x. That means multiply. So on top I got 9 times 4, which I can simplify to make 36. On the bottom, I now have 3 parentheses. The 4 is going to replace that x, 4 plus 2. I do the parentheses first. 4 plus 2 would be 6. So I got 3 parentheses 6, which is 3 times 6, which is 18. So the bottom of my fraction, the denominator, is 18. 36 divided by 18 is 2. Okay, hopefully, guys, this is all making sense. I'm trying to go slow. All right, hopefully you can follow these examples. Obviously, you can go back through this video if you miss anything. Okay, down here, there's just some guided examples for you to try on your own if you like. Okay, try it, check it on a calculator. Some 5, 6, and 7 have some grouping symbols in there for you. Okay, 8, 9, and 10, you got some fraction bars, some evaluating. You can give these a shot on your own. Best of luck.